Okay, so today we have the most missed problems from this unit, and we're going to, or I guess for the review, and we're going to kind of look through these 10 problems to prepare for the final, and we'll have one more of these tomorrow. So the first question, if you look, it says a combination lock has 50 numbers on it. How many 3-digit combinations are possible if no digits can be repeated? A common mistake would be to think that this is a combination problem, which it's not, because a combination problem, the order doesn't matter. But with a lock, when you're turning the dials, it does matter. Like 1, 2, 3 is a different combo than 2, 1, 3. So this situation is a permutation. So we're actually going to do 50 permutates 3 because you have 3 choices. And then we're just going to grab our calculator and go to math, probability, and I should have put 50 in first. Permutates 3. So that would be 117,600 possible combinations. Let's do the second problem. In this second problem it says from 9 names on a ballot, a committee will elect 4 of the people. And so this one is a combination because the order that you select the people don't matter because they're all going to be on the same committee. Like if they're chosen first or if they're chosen fourth, they're still just on the committee. So this would be 9 choose 4. And let's see if we can get that on our calculator. So 9 math probability NCR and then 4, and that would be 126. Let's try the next one. In this one, we want to know the probability of selecting a car or computer. If the probability of selecting a car is 65%, owning a computer is 82%, and owning both is 55%. So if you remember, the OR thing is the probability of A plus the probability of B minus the probability of the overlap is that OR situation. So that would be 0.65 plus 0.82 minus 0.55. And if we get that on our calculator, I'll just see what that is. So that'd be 0.65 plus 0.82 minus 0.55. And that should be our 92%. Let's try the next one. When I look at this, and I have to decide which statement is true, I'm going to read through the different statements. It says the first one, the linear model is okay because it's approximately the same number of points above and below. Well, that's not true because this thing makes a pattern, this U shape. So anytime we have a pattern, we know that this residual plot is telling us that our model is not okay. The model is okay? Nope. The model is no good because the correlation is near 0? No, that doesn't matter. The linear model is no good because some residuals are larger than others? Nope. The model is no good because there's a curve or a pattern? Yes. So anytime you see this residual idea, patterns are very bad because if you have a pattern, you could have picked a model that hits that pattern exactly. Like if you can predict, then you probably should have chosen something different and tried to match the prediction. This one, a politician claims in a speech that correlation research has clearly showed that a lack of education causes people to turn to a life of drugs. What's wrong with the claim? Correlation does not prove one variable causes another. That first one is definitely true. Because there's probably a multitude of factors on this. It's very hard to prove anything causes another thing. Just even if you think in this situation, like some third variables is maybe where they live can impact the access to drugs. So generally, like you could have people that have a lack of education that could live in certain areas which has more access to drugs. So their location could be a third variable. So there's a lot of things that could be in there besides that. So all the other things is not like as soon as you say correlation is causation, that's not true. Let's try the next one. which one has the largest standard deviation? So when we look across, standard deviation is how spread out the data is. This one has a spread, but when you kind of see from the center, everything's pretty much in the middle, like it's in the middle. And this one is crazy high in the middle, like everything is real close together. This one, you can see how far spread apart the extremes are. Like these points are pretty far away from these points. So the second one has the highest standard deviation, or that highest spread. Let's look at the next one. Okay, so it says given a 45% of the U.S. adults think Congress should place limits on carry-out bags. In a survey of 110 randomly chosen adults, people are asked, do you think Congress should place size limits on carry-on bags? Question, what's the probability that exactly 60 of the people answer yes? Well, because this situation is a yes and no situation, this would be a binomial distribution, because I have an exact number of people that I want to get correct out of 110. So I'd have 60 successes and 50 failures. Whenever you have a number of successes and a number of failures, that's binomial, because you have two things going on. Use the normal distribution of SAT writing scores in which 493 is the mean and 111 is the standard deviation. What percent is less than 600? So as soon as it says use a normal distribution, I'm going to go to my calculator and go to my normal CDF. And they want less than 600. So we'll go from 0 as our low end, 600 as our high end, and then our mean was 493, and our standard deviation was 111. And then we're going to find for this that is around 83%. Use a normal distribution. So again, as soon as they say use a normal distribution, we're going to use this normal CDF. And it has the same mean and standard deviation, but this time they want greater than 550. So we would start at 550. We'd go to some ridiculously high number. And then we would say 493 and then 111, because that's our standard deviation. And when I do that, I'd get around 30%. So that'd be A. Let's look at the last one. It says the mean height of men is 69 inches, a random sample. As soon as I see random sample, this is where I'm like, oh, this is a sampling distribution. So a sampling distribution, if you remember, will have the same mean, but it's going to have a different standard deviation. The standard deviation is going to be that over that. So we'll first find our standard deviation now. So their old standard deviation is 3. So our new standard deviation is going to be 3 over the square root of 60, because they took 60 samples. So that's around 0.39. And then, because it's over 30, this would be a normal distribution. So we're going to use our normal CDF again. And they want greater than 70, so we'll say 70 to some ridiculously high number. And then we want to go 60 to be our mean, and then we want our 69.9 to be our mean, and then our standard deviation was 0.39. And we can see that that's around 40%, so B would be our correct answer. If you get stuck with any of these problems, just let me know. They are the harder ones, but you really want to make sure for the final that you're ready to do these problems. And let me know if you need help.